All right, x and y intercepts. Thank you, gentlemen. Here we go. All right. Let's define what an x-intercept is. I'll write the word x-intercept, and then go ahead and write the definition. The point where a line crosses the x-axis. The y-coordinate is always 0. The point where a line crosses the x-axis, the y-coordinate is always 0. Write that down. All right. Give me a coordinate plane that goes up to 7 all the way around. So 7 positive, 7 negative, 7 positive, 7 negative, all the way around, please. And go ahead and draw a line with me. This line's going to cross the y-axis at 5 and cross the x-axis at 4. And go ahead and connect the line for me like that. Now, you don't have to write all the numbers down because I know where the numbers are at. You know where the numbers are at. There's no need to write the numbers down. Just give me an x and y axis and then draw a line that crosses the x-axis at 4 and the y-axis at 5. Do that for me. The point where a line crosses the x-axis. So earphones off right now because I have the floor, right, Rojas? So I have time to put those on later. So give me an x and y axis, and then give me just draw a line that goes to the x-axis at 4 and the y-axis at 5. You can see where it crosses the x and y axis here. Where is this line crossing the x-axis? Someone just blurt it out. 4, 0. Right? It's crossing the y-axis right here. Put an arrow right there, and let's go to write 4, 0. That is your x-intercept. Put a line from the word x-intercept. That's your x-intercept. It crosses the x-axis at that point. Notice how the y-coordinate is 0. Look at y is 0. Take note of that. That's what y-intercept means. Think of the word interception if you're a football player. Interception means the path of the football has met a defensive back, so it's an interception. The path of the football that was intended for the receiver intersected the path of the defensive back, so we call it interception, where two things meet. So the x-intercept is where the x-axis and the line meet. X-intercept. Y-intercept, on the other hand, we're going to define this one now. The point where a line crosses the y-axis, the x-coordinate is always 0. The x-coordinate is always 0. The point where a line crosses the y-axis, the x-coordinate is always 0. So where's that found here? Check this out. Look at where that line crosses the y-axis. The x is always 0, and the y was 5. Notice how x was 0. So put a line from the word y-intercept right there. That's the y-intercept, where a line crosses the y-axis. Notice how x is always 0. Very nice. Some of you have seen this before. We're dealing with linear functions, functions that become lines. If I ask you to graph a linear function, well, we can just use our x and y intercept knowledge. Let me explain. Go write example 1 now. Example 1. I'm going to write graph the linear function. Graph the linear function, and let me borrow one here. I'm going to draw this or write this equation down. 2x plus 4y equals 8. Let's graph this puppy. 2x plus 4y equals 8. Graph the linear function. Up in my A there. Okay, so before we graph it, let's go ahead and create a coordinate plane here. Let me get my coordinate plane. So go ahead and draw another x and y axis, somewhere along the line, somewhere by the equation on your graph paper. Again, you don't have to put the numbers. I know where the numbers are at. You know where the numbers are at. Don't put the numbers. Just give me a nice x and y axis, about 7 all the way around. Let's graph the linear function with our knowledge of x and y intercepts. In other words, based on what we just defined what an x and y intercept is. I'm going to do 2 quick examples and we're done. All right. Watch this. So let's graph this. On the side, look what I'm going to write. X-intercept, we'll write x-int, short for x-intercept. We'll put an ordered pair here, and then I'm going to write y-intercept, and an ordered pair parentheses here. Notice how easy this is to graph. It's going to be so easy.
So is the x-intercept 2 and then the y-intercept 4?
I'm not sure. Let's see. What's always 0 at the x-intercept, Aristotle?
The y-axis.
The y-intercept is always 0, the y-coordinate. So look, I'm going to put a 0 here. Where did I get that? Well, I got that from the definition. Look at the y-coordinate is always 0 at the x-intercept, always. So I'm making 0 there. And what about for this one?
The x-intercept is always 0.
The x-coordinate is always 0 at the y-intercept. Nice. Look at that. Knowing this, we can graph quickly. I'm talking fast. Notice how the y-intercept, the x-coordinate is always 0. Vice versa. So knowing that truth, watch what I'm going to do. To find the x-intercept, I'm going to replace y with 0. Wherever I see y, I'll replace it with 0. And then solve for x. Let's do that first. Here we go. Let me rewrite the function. 2x plus 4y equals 8. 2x plus 4y equals 8. I'm replacing y with 0. Watch this. 2x plus 4 times 0 equals 8.
0.
What is 4 times 0?
0.
Thank you. So all I have is 2x equals 8. So let's divide by 2 to get x alone. X then is 4. So that means our x-intercept ended up being 4, 0. Look at it.
Do you do the opposite to get the y-intercept?
Whatever you mean by opposite, I'm not sure.
Plug in 0 for 2x instead of
4x, huh? Yeah, but before we even get there, let's go and plot 4, 0. Plot it with me. 4, 0, check this out. Right, Rojas? Watch this. 4, 0, boom. Plot that with me. For the y-intercept, I'm going to use, I'll go black. (2x plus 4y equals 8). Now I'm going to replace x with 0 and solve for y to get the y-intercept. So 2 times 0 plus 4y is 8. 2 times 0 is 0, so I got 4y equaling 8. Thank you.
So y equals 2.
Y is 2. Look at our intercept. 0, 2. So let me plot that one now. Plot it with me. 0, 2 is right here. I'm ready to connect both points, and I'll have graphed the linear function easily by just using the x and y intercepts. Graph it with me. Easy stuff, you guys. Nothing crazy. Nothing crazy today. Absolutely. So I put the x-intercept in black, or the y-intercept in black, x-intercept in blue. No biggie. One more example and we're done. Quick one. Okay. Last example. Example 2. Graph using intercepts. Graph using intercepts. Last example. Let me get this one here. Right. There's your equation. Negative 5x plus 2y equals 20. Let me get a coordinate plane going. You might want to too because we're going to graph anyway. Let me get that ready. Oops. Let's get this ready. So far, so good. Let's graph this puppy. X-intercept, I'll put INT for short. I know what's always 0 to the settle there. What's always 0 to x-intercept? Thank you. And then the y-intercept, I'll abbreviate. X is always 0. Yay, this is fun. Your full dog, right, Costas? Let's rock and roll. Let's find the x-intercept first. Negative 5x plus 2y equals 20. Negative 5x plus 2y is 20. I'll replace y with 0. Watch me do it. Negative 5x plus 2 times 0 equals 20.
So negative 5x equals 20.
Thank you. Negative 5x equals 20.
Divided by 5.
Close. By negative 5, careful. X then is going to be a negative 4. If I'm not mistaken, my coffee kicked in. There it is, negative 4. Negative 4 is 0 for my x-intercept. Let me plot that puppy. Plot it with me. Negative 4 is 0 is right there. That's my x-intercept. I know however the linear function looks, it's going to cross the x-axis right there. At negative 4 is 0. I'll put the second one in black, just like last time. Now I'm going to find the y-intercept. I'm going to replace x with 0 now. Negative 5x plus 2y is 20. Therefore, negative 5 times 0 plus 2y is 20. Therefore, 2y is 20. Therefore, y is 10. There's my y-intercept, 0, 10. Kind of off my graph paper here, 7, 8, 9, 10 is right up here. We plot those 2 points, draw a line to them, we graph the linear function, ladies and gentlemen. A linear function.